Okay. Am I muted?
We can hear you, but you can't hear us.
Oh, I can't hear you. Okay, now I can hear you. I'm sorry, my volume was down. I apologize. Okay, what were the questions that you guys have? And thanks for texting me. I'm sorry, say that again. What was your question?
I don't think there was any questions. They just wanted to know what section we were on.
Oh, okay, we're on 3.1. I apologize, but I'm glad you guys texted me to let me know I'm muted. That I couldn't hear you. I think my volume was down. Okay. All right. Okay, so let's take a look. Okay. All right, so let's now work on this, and we get x plus 1/2 times 0. Okay. So go ahead and work on those over there. And what you'll see is for each one of these, you won't get a fraction. So you get x plus 1/2 times 2 is equal to 2. And what will happen is that these two will cross each other out. And then go ahead and do this last one. Okay. Now this over here is x plus 1/2 times 4 is equal to 2. X plus, so these will now cancel. 2 is equal to 2. Okay. So the next thing you want to do is you want to plot these points. Now, XYZ will only let you plot 2 points, but we do 3 just for error checking to make sure you don't get a triangle.
Hi, Professor.
Go ahead.
I still don't understand how you come up with the number 024 or 036.
Okay, so you're asking the right question. Okay. If I have a situation where one of my coefficients is a fraction, and in all these problems, only one of them will be a fraction. What you want to do is you want to count by twos, by whatever the denominator is. So if this is a denominator, if 2 is the denominator, 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. So you're skip counting, 0, 2, 4, 6. So for example, if I had something that looked like this, then in this case, the denominator is 5, and you would put 0, 5, 10. I'm just counting by fives.
I see. Thank you so much.
Okay. Okay. Now, the reason why we do that is you can sort of see how this 2 will cancel out that 2, and then this 4 will cancel out that 2. So when we count by the denominator, these automatically cancel, and then you don't get a fraction. Okay, so let's take a look at this now.
Professor,
go ahead.
Do I need this for Math 238?
Yeah, you do. In
Okay.
fact, we're going to do this. We'll do this a lot more in 238 than you will in trigonometry. So we'll actually do this.
Okay, thank you.
Yep. So then this will go 2, 0, 1, 2, and then 0, 4. Okay. And then, oh, Arthur, you're here. That's great. Okay, so Arthur, so far everything that we've covered is going to be in 238. So for the next week, everything is going to be on 238.
Okay, cool.
I'm glad to see you here. I didn't even notice you being here, but I'm glad you're here.
Okay, thanks.
Okay, now, so let's take a picture of this. Okay. Were those your copy? Go ahead and copy.
I'm sorry, isn't that last point
This one here?
the last point on the graph? Isn't
Yeah.
it the wrong place? If it says 0 is X and 4 is Y
Oh.
on the graph.
Yeah. So this one here is supposed to be the 0, 4. This one here is supposed to be the 2, 0.
Okay.
Okay, is that better? Okay, did everyone have a chance to copy? Okay, I'm going to flip it. If you need me to flip it back, I can. Okay. Now, the next heuristic, you have X or Y by itself. Okay. So I have something that looks like this. So I either have X or negative X, Y or negative Y all by itself, meaning that my coefficient is 1. Okay. Now what you want to do is put 0, 1, 2, the 3 easiest numbers in the other variable. So this is X by itself. So put 0, 1, 2 in the other variable.
Professor,
Go ahead.
what do you mean by x is by itself?
Meaning that the coefficient is 1 or -1.
Oh, okay, thank you.
Okay, so 1 or -1. So now I'm going to flip this. And I'm going to ask you to graph um, 2x minus y is equal to -1. Okay, so you can see how the y is all by itself. Okay, its coefficient is -1 in this case. So you're going to put 0, 1, 2 in the other variable. Okay, so go ahead and try that. Do the same thing we did over here, but what you're going to do is you're going to place x equals 0 into here, x equal 1 into here, and x equal 2 into here. This is So we have 2 times 0. Then we're going to divide both of these by -1. We have 4 minus y is equal to -1. Oh, I'm sorry. I put a, it's supposed to be a 1.
And you're dividing -1 because the y represents a 1, right?
Yes, yeah. So think of this minus as this minus y as -1 times y. The shorthand for that.
Okay, thank you.
Okay, then after you finish, you'll try graphing it. Now, the nice thing about all the techniques I'm showing you is that you kind of know it's the right answer because these will all be equally spaced, right? 3 minus 1 is 2, 5 minus 3 is 2. The other technique I showed you with the fractions, they'll be the same. If these numbers are wildly different, even before you graph them, you know that it's not correct. These should all be evenly spaced.
Professor.
Go ahead.
So question. So is it every single time that we do a graph like this, it's always going to be the 3 steps, like the 0, 1, 2, that we're going to equation for?
Yeah.
Okay.
So the reason why you do the third one is error checking. So when you actually graph it onto the computer, you'll just use 2 of them.
Okay, perfect. Thank you.
Yeah. So I have 0, 1. I have 1, 3. And I have 2, 5. And then we go down like that. Now, the third technique number 3 is that coefficients divide into the constant. So you see how the 2 and the 3 divide into the 6. So these okay. Now, whenever you have this situation, you just do 0, 0. You just do 2 points. Finding the third point is really hard, so then I just don't bother. Now, normally I don't give you any hint, but I think in XYZ, sometimes the way that they'll write this in your homework, it'll say find X and Y intercepts of the graph. Now, after we graph it, I'll show you what X and Y intercepts mean. Okay, but just know that if the question asks you, hey, graph this and use X and Y intercepts, they're trying to tell you 0, 0. Now, in real life, no one's going to tell you that. You're going to know to do that because these two numbers divide into them. So let's okay, so let me pop it over. Well, actually, let me give everyone a chance to copy first. Then I'll pop it over.
Professor, this is the same stuff that we did in 115, right?
Exactly same, no difference at all.
Okay.
Okay, feel familiar?
Yeah.
Okay, good. I'm glad.
Okay, perfect.
Okay, now I'm going to pop this over. And let's get a graph. Now, whenever you have a problem like this, what you do is when you come to a problem, okay, you ask yourself these questions from left to right. Does it have a fraction? If it does, I use a multiple of the denominator. Is there an x or y by itself? If there is, I put 0, 1, 2 in the other variable. If both of these have a coefficient and they're not a fraction, in this section, they'll almost always divide into there. Okay. So then we'll ask ourselves the questions from left to right. Is there a fraction? No. Is there an x or y by itself? No. Okay. Do both of these numbers divide into here? The answer is yes. So then we'll do 0, 0. Okay. So we get 4x minus 2y is equal to 8. And then go ahead and give that a try. And then we're going to divide both sides by -2. And over here, I have
Professor,
go ahead.
shouldn't the answer
Oh, be negative, huh?
Yeah.
Yeah, thank you.
Mhm.
Okay, I just noticed that too. Thank you. Okay. And then over here, we have 4x minus 2 times 0 is equal to 8. 4x is equal to 8. And then we're going to divide both sides by 4. And then x is equal to 2. So go ahead and graph that puppy. And we should have -4, and we should have 2. Goes down like that. Okay. Now, let's talk about what X and Y intercepts are. The X-intercept is when the graph hits the x-axis. And then the Y-intercept is when the line, when the graph hits the y-axis. Okay. Now, the way to get the x-intercepts is always to do 0, 0. And the reason why is that whenever I hit the y-axis, my x has to be equal to 0. It's that 0 that makes me hit it. Okay. Over here, what makes me hit it is when the y is equal to 0. So another way of thinking about this is the x-intercept is when y is equal to 0, and the y-intercept is when x is equal to 0. Okay, so let's erase this. I'm going to leave this here for those of you who are still copying. Okay. Now let's do the last little bit of this. Let's say we have something that looks like this. Graph y is equal to 3. Okay. Now, if I was to ask you to graph something like y equal to 3, what that means is that, well, y is equal to 3. get rid of this one. Good. Oh, this one's good. Okay. So we have y is equal to 3. Now you can pick any number you want for x. You can pick 0, 1, 19, 152.7. It doesn't matter what number you pick. Y is always equal to 3. Okay. So let's just take these two, our same ones, and let's just graph that.
Professor,
Go ahead.
where'd you get 0, 1, 19, and 152 from?
Oh, meaning that you can put any number here. It doesn't matter what number you put here. Y is going to be equal to 3.
Oh, okay.
So I'm just trying to demonstrate that, yeah, it could be completely random.
Okay.
But pick numbers that you like. 0 and 1. Okay, so the idea here is that this is what axis you're going through. You're going through the y-axis at 3. Okay. So when you see this, you don't have to actually plot it. You can just say, go through the y-axis at 3. And usually it doesn't fit your intuition. Usually when we say y, we're thinking up and down. Okay, so it's opposite your intuition. We're going through the y-axis at 3. Okay, so if I was to write this up, what we're doing is, well, actually, let me take a picture of that first, and we'll write that up. Okay. So for number 4 here, so if I have y is equal to 3, what you're doing is something that looks like this. Go through y-axis at 3. And in the same way, if you had something like x is equal to 2, you would go through the x-axis at 2. I don't even plot it. Let me give everyone a chance to copy. Okay, now. Okay, now I'm going to remind you that this weekend I'm going to put a practice quiz up so you can see how fast you have to be able to do the material, and just to sort of get you ready for the speed of the actual quiz. And then I'll put up the quiz 5 o'clock on Sunday, and then you have until class on Tuesday to do it, and it'll be a speed test. Okay. Now, by law, what happens is you have this day that you guys can drop the class and have no record on your transcript. What happens is after that date, by law, we then charge the state for every person that's in our class. So we're paid by student, we're not paid by class. So a class that has 40 students will make more money than a class that has 30 students. Now, if it is illegal for us to charge the state for a student who doesn't come. So like if you're a student who has never shown up, you forgot that you enrolled, or you died, or something happened, you just never came to class, it's illegal for us to charge the school. So we have to kick out anyone who has never shown up. Now, because we have this weird virtual classroom where it's really hard to do attendance, the only way I'm going to do attendance is whether you're doing the XYZ homework. So if you haven't been doing the XYZ homework and you still want to be in this class, please email me by tonight, right? Let me know what your circumstance is. You're going to have to do the quiz on XYZ homework. So most likely what will happen is Wednesday night, I will drop anyone who didn't take the quiz, who hasn't been doing homework, okay? Now, if something happened to you, which is why you haven't used the XYZ homework, you need to email me so I know not to drop you from the class. Now, if by mistake I drop you, let's say someone got coronavirus, they actually know this material really well, they got coronavirus, they've been sick in the hospital for 2 weeks, but they weren't able to do homework, wasn't able to do the quiz, and then they come back to me week 2 and go, I feel okay now, can I still be part of the class even though you dropped me? And the answer is yes. Even though I drop you, I can do some kind of paperwork, I can figure it out in terms of how to re-add you into the class. Now, it's a big pain because normally I would write a slip out and then you would take it to admissions and they would just add you. And now I have to call somebody to say, because I'm not allowed on campus, how do we make this happen? Okay, so I have no problem figuring that out. But if something happens where you get dropped from the class and you say, oh, you didn't understand my circumstance, let me know and I will re-add you to the class, okay? But it's easier if you have a special circumstance that you email me just so I can put a little dot next to your name to make sure that I don't drop you, Okay. Let's go to let's go to the haiku. Okay. Now on the haiku, I have some graphing worksheets. So let me put these all the way up on the left. So I'll show you. Okay. Now, like I said, I already know what questions you're going to get wrong. So this right here is the video for how to graph this whole thing that we just did. And this graphing linear equations is how I used to put it on the exam before I did XYZ. So let's make it a little bigger. Okay. So if you need to practice doing this and you don't want to go to the XYZ and you just want to bang out problem after problem after problem, this is probably the fastest way to do it. Okay. So it has one of each. Look, here's a problem that has a fraction. Here's a problem that has X or Y all by itself. Here's a problem where the 2 and the 3 divide into the 6. And then here's one where it's a vertical or horizontal line. And each one of these, you can see that there's 4. And that's how I'm going to do the test. I'm going to give you one of every kind. Okay. So if you want to bang out problems, this is probably the fastest way of doing it.
And the answers are attached, right?
Yep. The answers are in this second one right here. Yeah. So any question I ever give you will always have an answer. Okay. I think it's a waste of time to do a problem where you don't know if you got it right or wrong because you might be practicing a mistake. So this will, the fastest way to like practice these, because I'm going to give you 4 of these. So it's going to be an outsized, the weight of these questions is going to be worth more than other sections, which is something I intend also. Okay. So that's probably the easiest way to study. Now we're going to walk into, after this section, into this worksheet here. I think I emailed it to you. I also texted it to you. Just know that those solutions are all here also. Okay, so every worksheet I ever give you will always have a companion solution set. Okay, now let's take a 10-minute break, and what we'll do is we'll drill ourselves on what numbers that we should plug in. So we're not quite done with this. We're going to do, all the content is done, but we're going to practice it a little bit more. Okay, so right now it is 9:03. So let's take a break to 9:15. Okay, thanks everyone. I'll put this back to what we had.
We're asked to solve the given absolute value equation. Normally, when solving an absolute value equation, we expect two solutions, but that's not always the case. Let's attempt to solve this equation and see what happens. We have 11 plus the absolute value of the quantity 3x plus 2 equals 8. The first step in any absolute value equation is to isolate the absolute value. To undo this positive 11, we subtract 11 on both sides of the equation. And now we simplify. 11 minus 11 is 0, so the left side simplifies to the absolute value of the quantity 3x plus 2 equals 8 minus 11 is equal to negative 3. Notice now we have the absolute value of the quantity 3x plus 2 is equal to negative 3. And this is a problem because the absolute value of a number or expression describes its distance from 0 on a number line. And since the absolute value expresses only the distance, not the direction of the number on a number line, it is always expressed as a positive number or 0. So because an absolute value is never going to be negative, this indicates the original equation has no solution or no solutions. So let's say the equation has no solution.
Okay, so let's practice a little bit.
Professor,
Yeah. What's up?
before the break, you were talking about like points, about how some things would weigh more than others. Can you re-explain what you were talking about?
Yeah. Normally what's going to happen is like every section, I'm going to pull out, 2 questions, 3 questions, right? So from this question, I'm going to pull out at least 4 questions to make you graph.
Right.
So not every section is worth the same amount of points.
Mm-hmm.
So for the and or section, I'm probably going to pull out 2 questions. For the absolute value, I'm probably going to pull out 4 questions. Now, once you put it on the test, each question is worth the same amount. So learning this is worth 4 questions. Learning ands and ors is worth 2 questions.
Okay, that's what
That
you
makes
mean.
sense? Yeah.
Yeah.
So
thank you so much.
yeah. So this is worth twice as much as learning how to do ands and ors, and then it should be because it's that much more valuable, right? What's valuable isn't based on what's hard. It's what's used most often in your next classes or in your job.
So this will be used twice as much in trig than and or problems?
Oh, the and or you'll probably never see again.
Oh, okay. All right.
Okay, so the and or if you go heavy into statistics, and not even the first statistics class, you got to go into take a real statistics class for statisticians. You'll see and or. If you take a philosophy class and they teach you logic, you'll see and or. Or if you take an engineering class, they'll teach you and or. But in terms of just a regular human being, like I'm a sociologist, I'm a business major, you'll never see that again.
Okay.
Okay. Yeah. The chip that's in your computer is completely made of and or logic. So if you go, who uses this the most? Either philosophers in logic tables, but really computer engineers and electrical engineers. Your entire chip is basically made out of and or logic. Okay. Let's get moving. So I just want to teach you that if you see a random problem, right? So we're not going to actually draw it. I'm just going to put it up, and you're going to have to figure out what values you're going to put in there. Okay. Now, when you get something like this, what you'll do is you'll go left to right. You'll go, do I see a fraction? No. Do I see X or Y by itself? Yes. So that's why you'll put 0, 1, 2 in there. Okay. So that's the game that we're playing. Which variable and what number am I putting in there? Okay. So then go ahead and try doing this one. And try doing this one.
Professor, should it be the first one, the 0, 1, 2 be in the 2x?
Oh, I'm sorry. You're right. It should be in the other one. Yeah. Thank you. Thank you. Okay, so this one over here, 0, 5, 10, because it has a fraction in it. And then this one will be 0, 0, because there's no fraction, there's no X or Y by itself. You just have 3 and 3 divided into 9. Okay. So let's just try it one more time. All right, so you ask your questions left to right. Okay, so if we look at the first one, no fraction, no x or y by itself. So this one should be 0, 0. Okay, now go left to right. This one has a fraction. 0, 3, 6. And then this one, no fraction, but there's an x or y by itself. So 0, 1, 2. Okay, let's do another series. Okay, so let's look at this first one. Going left to right. Does it have a fraction? Yes. So we're going to use 0, 4, 6. And then going left to right. Does this one have a fraction? No. Do you have an x or y by itself? No. Do both of these divide into there? Yes. So we can use 0, 0. Now when we go this one, does it have a fraction? No. Is there an x or y by itself? The answer is yes. Okay. Now, let's say you're taking this test, and we get to this graphing question, and you go, "Oh my God, I can't remember the rules." Just randomly start putting numbers in it. 0, 1, 2. Put them in the x or y. Get 2 of them that don't give you a fraction, and that works too. Okay, so I'm teaching you this so you don't have to do that. But if you're in trig or if you are taking the final, you completely forgot how to do this. Just put in 0, 1, 2 for x and 0, 1, 2 for y, and pick the first 2 that don't give you a fraction. And you go, does that work? Like, yeah, usually it works. Okay. Now I want to do two problems with you, just to make sure that we're all on the same page. Okay. So let me take a picture of this.
Professor, would it be wrong for the first one to use 048 instead of 046?
Oh, I'm sorry, 048. You're right. 048. I don't know where I got 6 from. That's bad. I'm glad you got that. Let me erase that picture.
For the problems that you put on the left side, the last one, x minus 3y equals 2, shouldn't the 0 to 1 be under the 3y?
Yeah, I must be having a stroke or something.
Or
Thank you for catching all my mistakes.
Wait,
All right. No, I was on the right one. It's on,
on
the,
the
other
other
one.
side.
So I'm
Yeah.
okay. So
On
actually,
the
I'm
other
just
side.
yeah. So we're okay. I'm just a person who's very low with very low self-esteem. So if you suggest something, I'm probably going to agree. All right. So we were okay on this one. All right. Now let's flip this. Okay. So let's just work on 3 problems. Okay. Sometimes some problems you can use 2 different techniques. So let's say I ask you to graph x plus 2y is equal to 4. Okay. Now you have an x by itself, so you can use this 0, 1, 2, and the other one, but 1 divides it to 4 and 2 divides it to 4. So you can also do this. They're both correct. Sometimes I have students who will just leave the question blank because they'll freak out and go, I don't know which one, so I'll do none. Sometimes more than one technique will work. Just pick the one that you like better and move on with that one. Okay. Now, so there's 2 questions I want you to work on. Okay. One of them looks like this. Okay, so go ahead and try doing both of those. So these 2 are different because this one has a y. So this one will be the go through the x-axis through 2. Okay. For this one is similar to this one, where you'll ask yourself, do I have a fraction? No. Do I have an x by itself? Yes. So let me put in 0, 1, 2. So even though you don't see a number here like this, it doesn't matter. All the rules still work. Okay. So go ahead and do the next steps. Oh, I'm sorry. These should all be Y's. My bad. Sorry. Okay, so then when we graph this, should get 0, 0, 2, 1, 4, 2. And then graph that other one. I think it works. So when we're doing this one, we're saying go through x-axis at 2. So I'm going through the x-axis at 2. Okay, so this is done. Okay, so I'm gonna, well, I'll just leave this. We're gonna start section 3.2. I'm gonna erase this side of the board. Okay. Now, section 3.2 is yet another little monster section, meaning that there is a lot here, and there's also a lot of weight to this section because it's essentially what calculus is. So for those of you who are going to take business calculus or calculus, the 3.2 is an extremely important section. Okay. So we're going to go to section 3.2.
What's the name of the section, Professor?
It's going to be slopes. Okay, we'll talk about what slope is. And the nice thing about slope of what it is very intuitive. Okay. Now, the way slope is explained is generally pretty poorly. The standard way you start this section is you go slope is equal to rise over run. And my question is, what the hell is that? We don't use the word rise in the way it's used here in regular English. And we don't use the run in the way it's written here in regular English. So we're basically translating this very intuitive concept in a way that is garbled because the words we use are not very good. What I like to use is up, over, right. How far up did you go versus how far right did you go? Okay. Now, this vocabulary comes from stairs. So let's say I was to create some stairs. Okay, and this is two, I don't know, we'll say, I guess, how wide's a stair? This is 5 inches, this is 7 inches. This is 5 inches, this is 7 inches. This is the run, and this is the rise. So when you're building stairs, this is where the vocabulary comes from. They'll ask you, what's the run? 5 inches. That's how flat it is. And they'll go, what's the rise? You know, how far do I go up when I take another step? It'll be 7 inches. So the vocabulary comes from this idea is that this is set. If I ask you how many up over how many over, this is 7 over 5. Right? For every 5 inches that I'm moving in this direction, I'm going up 7. Okay, and just like stairs, this slope continues to be exactly the same for stairs or for a line. Okay, so another way to think about slope is direction. So let's say I'm sitting here at a bar with my guy friends, and we're dudes. And what do dudes talk about when you're at a bar? You're talking about pretty girls. And you want to tell your friend where the pretty girl is. And what you'll do is you'll say, hey, look forward 10 feet, and then look right 5 feet. And then there is the pretty girl. Right? So if I'm sitting with my guy friend and then we're both hounds and we're looking like, woo, look at that girl. The way I express direction is exactly how we talk about slope. Look forward 10 feet and then go over 5 feet, and there's the pretty girl. So at the end of the day, if you say, what the heck is slope? It's direction. What direction is this line going? Now, whenever we talk about a line, we always discuss it going left to right. So that's why I say 5 to the right, 7 up. Okay, because we're always talking about this left to right. Okay. Now, the reason why this is used in business calculus so much is that a lot of how we talk about profits or salary has to do with slope. Like, let's just think of the basic situation in terms of payroll. Okay, so I make $15 an hour. And if I call you into work, I have to pay for your parking. So whether you work 1 hour, you work 10 hours, I have to pay for your car to be parked. So 10 hours for parking. Right? So if you work 1 hour, you get $15. I'm sorry, $25. If you work 2 hours, you get $40. And if you work 3 hours, you get $55. Your salary is the slope. Okay. So if we're asking every time I work an extra hour, how much money do I make? 15, that's my slope. Now think about business, right? You're doing this with almost every metric. For every hour, what's my revenue? For every hour, what's my cost? For every hour, what's my profit? For every hour, what's my interest? So you're always talking for every whatever, how much money am I making? How much money am I losing? How much money is it costing me? Slope is that fundamental thing, that per hour metric, okay? So that's why in business calc, that's why in science, slope is a fundamental concept. Every step, right? Every time we take a step, how far up do I go? Okay, so let's take a picture of this. Okay, now, there are a couple ways that we can see a slope. Okay. So we have a situation where it looks like a triangle going up. It's a triangle going down. It's horizontal, and then it's vertical. Okay. Now, whenever we're looking at slope, we always go left to right. Okay. So go ahead, copy that. Okay. Now, we always go left to right. So you can either go this direction, or you can go this direction. It doesn't matter. It doesn't matter whether I go right first or I go up first. You'll get the same you'll get the same value because slope is equal to up over right. Okay, so over here, how many up did I go? 3. Oh, I'm sorry, this should be 2. That should be 3. Okay. How many up did I go? 2. And how many to the right did I go? 3. So it's not which way did I go first over which way did I go second. It's always how much to the right did I go? I'm sorry, how much up did I go over how much to the right I go? So whether you do this way or this way, you're going to reorient it so the up is always on top. Now, because we are reading left to right, when I'm going from here to here, right, this is the leftmost location. I'm going down and then to the right. So whenever we do down, that makes it a negative, right? It's negative because it's down. So then I look at my slope, it's equal to up over right. So this is equal to -2 over 3. Okay. Now for this one, we're not going up at all. We're only moving, we can pick any number we want, okay? But we're not going up. So the slope of a horizontal line is always 0. Okay. So these graphs are how we actually draw profit. So if I were to ask you every hour, how much profit am I making? You're making no profit. You're 0. It's not going up at all. You're not making any money. Slope is 0. Now, in this case, we can pick any 2 points on this line. Let's just call it 3. So we're going up 3, but we're not going horizontal at all. Right? We're going up 3, but we're not going left or right at all. So then the slope of a vertical line is undefined. Sometimes they'll go like that. Sometimes they'll do no solution. Any of those are fine. Picture of this. So if we have
In
a
this
line
video, we'll take
that's
a look at
going
solving
up,
two absolute value
we have a
inequalities.
positive slope.
We'll express each as a compound inequality, a graph, and using
If you have
interval
a line
notation.
going down,
In the first example, we have the absolute
you
value
have
of 2x
negative
plus
slope.
3 is less than 7. So the first thing to recognize here is we're looking for values of x so that 2x plus 3 would have a distance from 0
If you have
less than 7.
horizontal,
And since the original inequality symbol is less than, we're going to write this
slope
as
is
two inequalities
equal to
connected by the word
0.
and,
And if you have
which means we're
vertical,
looking for the intersection of two linear inequalities. The first inequality is going to be
slope
2x plus
is
3
equal to undefined.
is less than 7. So notice how for this inequality, we just
When you
drop
get to
the
calculus,
absolute
we'll say
value,
it's equal to infinity, but we're not there
and
yet.
2x plus 3 must be greater than negative 7. So for the second inequality, we drop the absolute value, reverse the inequality symbol, and change the sign of the 7. So now we'll solve these and then graph the intersection of the two on the number line. So here we'll subtract 3 on both sides. This would be 2x less than 4. Divide both sides by 2. So we have x is less than 2. And now we'll solve the second inequality.
So
subtract 3 on both
this
sides.
goes together,
Should be 0.
that goes
So we have
together,
2x
and then that goes
greater
together.
than negative 10. Divide both sides by 2. And we have x is greater than negative 5. So here's the solution as a compound inequality. So now we'll graph these two and look for the intersection. So we have x is less than 2. So open point on 2, arrow to the left. And x has to be greater than negative 5. So we have an open point on negative 5, arrow to the right.
Okay.
Now this is not the
Now,
graph of our solution.
let's break out that
We're looking
worksheet.
for the intersection of these two intervals, which is the interval that's been graphed twice. So we can see it's going to be the interval between negative 5 and positive
Oops,
2.
let me grab some glasses.
So let's go ahead. Minus 1 would have a distance from 0 that's greater than 5 units. And since the original inequality symbol is greater than or equal to, we'll have two inequalities connected by the word or. So the first inequality is going to be 3x minus 1 is greater than or equal to 5. So the first inequality, we just drop the absolute value. Or for the second inequality, we drop the absolute value, reverse the inequality symbol, so it's going to be less than or equal to, and then change the sign of the 5, so we have
So let's
5.
pop that up.
So now we'll solve and graph these two inequalities, and the solution will be the union of these two intervals.
Okay. Now what we want to do is we want to find the slope for C, D, A, and B. Go ahead and see if you can do it. Okay. The C and D at least should be easy because a horizontal line always has the same slope and the vertical line always has the same slope. Oh, sorry. All right. I stole this drawing thing from my daughter, so we'll see if it works. Okay. So the slope for a horizontal line is always 0. Okay. Now just know that that slope, because it happens so often, we gave it a letter, M. So just like Prince has his own letter that represents himself, slope has its own letter that represents itself. So M is equal to the slope. Okay, so the horizontal line, the slope is equal to 0. And then for a vertical line, the slope is equal to undefined. Okay, so let's do B first. Now, what you want to do whenever you're trying to compute slope is you're always want to start from the leftmost point. So this is the leftmost point. On this line, this is the leftmost point. So you want to start from the leftmost point and you want to draw a triangle. So over here you have this and then you have that. Over here you have this and then you have this. And now you're just counting boxes. So over here, this distance here is just 1. Oops. Right? I'm going 1 to the right, and then this distance over here, let's see if we can get a better color. Sorry. Then this distance over here is 2. All you're doing is counting boxes. So when I am going from here to here, I'm going 1 box over, 2 boxes up. Okay? So when I write my slope, I'm going 2 up over 1 to the right, which is equal to 2. Let me put that in a different place. Oh, it doesn't let me. Okay. Over here, when we are counting boxes, I'm going down. So over here, I'm going -1 down. Oops. Sorry, it's like an old man with technology. And then we're going 2 to the right. So in this case, our slope is equal to 1 down and then 2 to the right. Okay, so try doing the same thing over here. Do the horizontal and vertical ones first, and then draw your triangles, right? One will be positive, one will be negative. Okay, and do the slope on the ones over here. Right, let's do the horizontal and vertical ones first. The slope of this one. And then the slope of this one, of D. Let me move it over here a little bit, just so it's not in the way. Okay. Now go ahead and do B, right? Draw your triangle. Oh, shoot, I didn't go. Okay. Now the height of this is 3. It's going 1 to the right. So my slope is 3 over 1. It looks like a little kid wrote that, huh? Is equal to 3. Okay. Now when we do C, we're always going left to right. So this one is 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5. So we're going down -5. And then over here, we're going right 3. So over there, our slope is -5 divided by 3. Okay. Now, this is the thing I want you to sort of get out of this, okay? Because this is the thing you're going to take to calculus for those of you who are business majors, okay? Now, when I go back to what we were originally talking about, I want to go back to this example right here, okay? What the slope is how much money I'm making every hour. What's the difference? Every hour I work, I'm making $15 more, right? Every hour I work, I make $15 more. I'm not making a total of $15 because there's also this extra $10 for parking, but the difference between hour 1 and hour 2 is 15. The difference in the amount of money I'm making hour 2 to hour 3 is 15, right? So that's telling us each hour I'm making $15. Now let's go back to what we were doing.
In this word, or. So the first inequality is going to be 3x minus 1 is greater than or equal to 5.
Now I want you to think of this as
inequality, we just
stairs.
drop the absolute value.
So if I go to
or
the
second inequality, we drop the absolute value, reverse the inequality symbol, so it's going to be
so
less
if we
than or
go
equal
to this one over here,
and then
my
change the
slope
sign
here
5,
is
so we have
2,
-5.
meaning that
So now
every
we'll
time I
solve and
take a
graph these
step,
two inequalities.
I go up
In the
2.
solution, we have x's,
I go
3x
up
is less than
2.
or equal to, and
I
graph
go
these.
up
For x is
2.
greater than or equal to 2.
Over here, if I
This
work 1
does
hour
include the
less,
value of 2,
I
so we make a
lose
closed
$2.
point here.
So what you can see is that
Arrow
what
to the
slope
right
is,
for the numbers greater
it
than
is
2.
every
Then for
time I
negative
take a
4
step,
thirds, that's going to be
how
in
high is
between
my
negative
step in
1 and
Y,
negative 2, closer to
right?
negative 1.
So over here
Let's
on
just
this
say it's
B, every
here.
time I take a step, I
Make a
go
closed point
2
on
boxes
negative 4
higher.
thirds.
Now, if
And
we were
then
to
for
look at
values
number
less than negative
A,
4, we have an arrow to the
this
left.
one over here, my slope for that one was
So as we move to the
a
right, we're
half,
approaching positive
meaning
infinity.
that when I go
To the
from
left, we're
here
approaching
to
negative
here,
infinity.
I went down half a
So
box.
using interval notation,
And then when I go
the
down
interval
from
from
here to
negative 4
here,
thirds
I
to
go down
negative
half a
infinity,
box, and
including
then
negative
half a
4
box,
thirds.
and then
We'll have
half
negative
a box.
infinity, negative 4
So what the
thirds.
slope tells
Show the
you is
interval
that
includes 4
every
thirds. We'll
time
make a
I
square
move
bracket
1
here,
x to the
a rounded
right,
parenthesis on
how
negative
far
infinity.
up or how far
Or,
down
instead
do
of
I
using
go?
or, sometimes you'll see texts use u for a union. It means the same thing. And then the interval from 2 to infinity, including 2, will be closed on 2. And then we'll use a rounded parenthesis on positive infinity.
Okay, so let's go to page 2. And
Okay, that's going to do it for
the
these
slope
two
of those
examples.
4. Okay, let me share screen it. Okay, so go ahead and find the slope of each one of those lines. So I'll do the vertical and horizontal ones first. So if you're horizontal, your slope is equal to 0. And if you're vertical, your slope is equal to undefined. Okay. So for A and B, draw your little triangles. Now, on your homework, they may not, actually, they definitely don't put dots there. What you do is you look for where it goes through a corner. Oops, that was bad. Okay. What you do is you look for them going through a corner. Okay, so it went through that corner, and then it went through this corner. Over here, we go through this corner, and they go to there. So this slope here, we went 1 to the right, and then up and down, we went 1, 2, 3, 4, 5. We went 5. So then my slope is 5 over 1. And then we simplify, that's equal to 5. So sometimes you'll get a fraction, and you just simplify that fraction. Okay. This one over here is -1. And then we go 4 to the right. Okay. So does anyone have questions on how to do this slope at all? So I'm going to give you as many as they have on the exam, mostly because this is a real important concept. It's not hard. All you have to do is learn how to count. So if you can count and know up and down over left and right, you should get these right. Okay. So let me show you what it looks like in your homework. So let me pop that up. Oops. Stop sharing. So this is section 3.2. Get the right question up. All right, let's do this question. All right. Let me share screen. Okay, so try and find the slope. Okay, so you're looking for when did the line go through a corner?
In this video, we'll take a look at solving intersection. So we have x is less than 2. So open point on 2, arrow to the left. And x has to be greater than -5. So we have an open point on -5, arrow to the right.
Okay. So if you look
Now,
at
this
where
is
the
not the
line
graph
went
of
through
our
a
solution
corner,
because we're looking
you
for the
can look at it
intersection
right
of these two
here.
intervals, which is the interval that's been graphed twice. So we can see it's going to be the interval between -5
You
and
can look at it right
2.
here.
So let's go ahead and clean this up.
You can look at it right here. You can look at
Graph
it
of
right
our solution
here,
would be this interval here.
or you can look at it right here.
Which means using
Okay.
interval notation,
Any of those work.
we have the open interval from -5 to +2. So we use a rounded parenthesis here as well as here to show the endpoints are not included. Now let's go ahead and take a look at a second example.
Now,
Here we have the absolute value
you
of
can go
3x
from
minus
any
1
to any point
is
to
greater
any
than
point that goes through a corner. So let's say I do this one. Oops. Let me erase that. All right, let's go corner to corner. So I go, oh, sorry. So let's say I go from here to here, right? I went 3 to the right, and I went 1 up and down. So then my slope is equal to 1 over 3. Okay. Now, if you wanted to, because you're a psychotic, let's say you did this where you said, well, I didn't notice that those two went through the corner, and I only noticed that, sorry. I only noticed that this one and this one. Now it'll still work as long as you pick 2 corners. Now over here you'll get 2, and down here you'll get 6. So then you'll get the slope will be equal to 2 over 6, which is, when you simplify, it's equal to 1/3. So if you pick corners that are further apart, it's okay. You just have to simplify your fraction. Okay, now, when we go back to, oh, not that one. Okay, let's clear everything. Okay. Now, there's a bunch of other questions that said find the y-intercept. I'm not going to worry about those. They're not in your homework. They're not difficult. All you're asking for is where does this line hit this line? Well, it hits it here at 1, 2, 3, 4, 5. So my y-intercept would be 5. So we're going to skip those problems because it's not in your homework. But if you happen to look at them, the x-intercept of this line D is 4, right? Because this goes through, hits the x-axis at 4. But if I ask you what's the y-intercept of it, it's undefined, meaning that this line will never hit the y-axis. Okay. The x-intercept for this one is -3, but since it never hits the x-axis, it's undefined. So if you want to do those questions, that's fine. But the ones I'm really concerned with is basically A through D, and then we'll see about H, I, J, K. Some of that is in your homework, and some of it isn't. But the intercept really isn't in the XYZ very much. And since the test is based off of the XYZ, I'm not going to emphasize this very much. Okay, but it's not a hard concept. Okay, does anyone have questions about slope? Okay, so we're going to keep working on this section. We probably won't finish it. Yeah, go ahead.
I just have one question about what we'll see on XYZ.
Exactly what I showed you. Remember that second one?
Yeah, but it's just for overview. It's just going to be what's the slope of this line?
Yeah, it'll be one line. Yeah.
Okay.
Okay. The reason
why ask for XY intercepts or then asking for the whole equation of a line?
It will, but not in this section.
Not in this section. Okay.
We'll slowly work to that. Yeah. So this section is only slope.
Mm-hmm.
And then the only time they ask you for they'll ask you for the y-intercept, but not x-intercept. But that's coming up. We'll get to that. Okay. Okay. All right. So far, the only question that we've covered on your homework is that one I showed you. That's the only one. Okay. And I'll probably give you one where the line is going up and one where the line is going down. So you get used to giving me a positive slope back and a negative slope back. Okay, so let's take a little 10-minute break. Let's come back at 10:30, and then we'll knock out another hour. We may finish this, we may not. This is a pretty long section, so we'll see where we are.
In this 5. So now we'll solve and graph these two inequalities, and the solution will be the union of these two intervals. So here we'll add 1 to both sides. This should be 3x greater than or equal to 6. Divide both sides by 3. So we have x is greater than or equal to positive 2, or, then we'll solve the second inequality. This will be 0. We have 3x is less than or equal to negative 4. Divide both sides by 3. So x is less than or equal to negative 4/3. So now we'll graph these. For x is greater than or equal to 2, this does include the value of 2, so we make a closed point here, arrow to the right, for the numbers greater than 2. And then for negative 4/3, that's going to be in between negative 1 and negative 2, closer to negative 1. Let's just say it's here. So make a closed point on negative 4/3. And then for values less than negative 4, we have an arrow to the left. So as we move to the right, we're approaching positive
Okay, so let's finish up our last hour. Okay. Couple things. There are going to be a couple ways in which I ask you to find the slope. Okay. The first one is I'm going to from a graph. Right? I'm going to have something like this, and I'm going to say find the slope, and you'll use this as a guide. Okay. The second way I'll ask you to find the slope is from 2 points. And then the third way is from an equation. Okay. So just know that when you go through here, you'll feel like, I feel like you keep asking me to find slope, but I feel like these problems are all different. And the answer is, yeah, they are. The starting point is different. So I'll give you I'll draw a line and I'll say, find the slope. And then I'll give you 2 points and I'll say, find the slope. And then I'll say, here's an equation, find the slope. So what we're going to do now is we're going to do the number 2 part. Okay. So let's look at the one, let's look at a question like this. Okay. Now, most students like this question because this is the way they remember doing slopes. Most students weren't asked to do this or didn't remember how to do that. But usually they're happy with this. Okay, so go ahead and copy that because of the formula. So we're going to get something that looks like this. The formula for a slope from 2 points is y2 minus y1 over x2 minus x1. Okay. Now, it doesn't matter which ones are the y1s, x1s, and which ones are the y2, x2. So you are allowed to call this one x1, y1, or you can call this x2, y2. As long as the numbers that, as long as either the 2 and 3 come first, or the -5 and -1 come first. So as long as this is consistently, both of these are in front, or both of these are in front, it doesn't matter which order you do it. So what I like to do is just say, I'm going to subtract the y's. Okay, so this turns into something minus something. So I'm going to subtract the y's. And then I'm going to subtract the x's. And then I'll end up getting 4 over 7. And as long as that's simplified, that's fine. Now, whenever I say it doesn't matter which number comes, which numbers come first, I always have people go, I really don't believe you. I really believe that's got to be the y2. Why? Because it's the second one in the column. So if we were to do it that way, where this number comes first and that number comes first, and then I'm going to subtract them. You'll get the same answer because a negative divided by negative is a positive. So go ahead and copy that, and then I'll give you a fresh one to try out yourself. Okay, so let me flip this. And then let me erase this. All right, give that puppy a shot. Okay, so you're working off of So remember, when you do this, there's always going to be a subtraction that comes from the formula. So the y's are on top, and the x's are on the bottom. Okay. So if the 2 is first on top, the -5 has to be top on the bottom. It has to be first on the bottom. If -10 is first on the top, then 3 has to be first on the bottom. So now this becomes 12 over -8, and you've got to remember to simplify or it's wrong. So 4 divides into both of these, and if you don't see it, both of these are even, so you can get -6 over 4. These are both still even, and you can get to -3 over 2. Okay, so let's take a look at this. Okay. Okay, so you've got two of those questions, and there is 100% certainty that this will be on your test. Okay, now let's do this third one from an equation. Okay, so let me give you something that looks like this. Then let me use the entire board. So let me get out of your way. Okay. Now, there are different ways of writing a line equation. In the past, we said, let's see, forms of line equations. Okay. Now, in the past, I said this is the standard form. AX plus BY is equal to C. And because it says standard, it feels like it should be the most important one. But it's actually the one that we really don't use much in this class. It's standard because it helps us talk about lines in other dimensions, 3 dimensions, 4 dimensions, 5 dimensions. If you go, what the heck is that? Later, we'll talk about it later, okay? Not yet. For the most part, the form of the line equation that you're going to use, the line equation form that you're going to use the most is slope-intercept. Okay, meaning that what I want to do for slope-intercept is I want to isolate the y. Once I isolate the y, whatever number is here is my slope. Whatever number is here, not next to the x, is my y-intercept. Okay, so go ahead and try and see if you can isolate this y. Actually, let me do it for you first, because this first step is a little weird. Okay. Now, what I want to do is I want to isolate this y. Okay, so let's kind of give you guys a little notes. So the first thing I want to do is I want this y to be all by itself, just like it is over here. So what I'm going to do is I'm going to get rid of this 2x. Now I cannot combine the x with the 6 because this has an x and that has a number. You can't combine them. So you end up getting something that looks like 3y is equal to negative 2x plus 6. Okay? So go ahead and copy that. And usually people have questions on that move. Okay, so let's think about this. Now, don't copy what I'm going to write. If the problem looked like this, let's just say, and you're trying to isolate the y. Normally what you would do, you subtract 2, and because that's a number and because that's a number, you could actually do 6 minus 2 is equal to 4. The difference over here is that this is 2x. You cannot subtract an x from a number. They're two different items. So that's why we just put it next to it. Now, the next move is to divide everything out by 3. Okay, so I have 3y is equal to minus 2x plus 6, and I'm going to divide everything by 3. So this right here is my slope, and this right here is my y-intercept. Okay, the number all by itself, the sign goes with the number. Okay, so your slope is a number. Don't put the x there, right? It's the number next to the x. So my answer would be the slope is equal to negative 2/3, and the y-intercept is equal to positive 2. Okay, don't put an x here, it'll be wrong. So let's try this again. Now, I just want to remind people, okay, you're going to get the quiz on Sunday. Don't cheat. And it's not a don't cheat for my sake. It's a don't cheat for your sake. This is an optional class. You do not have to take this class. Your grade in this class is not part of your transfer GPA. Meaning that if you get an A in here, and you go and you apply to CSUN, they don't even record it in your GPA. If you get a C in here, they don't record it in your GPA. So you're taking a completely optional class where if you get an A or C, it does not change how the school you're transferring to looks at you. Okay. The reason why you're taking this is that people who don't take this class, 30% of them pass 238, and only 30% of them pass 259. Only 30%, 1 out of 3. Okay. Now, if you get an A or B in here, you've got like a 50% chance of passing the next class. It's not even like overwhelmingly you're going to pass. You may have to take it twice for business calculus and for stats and for trigonometry. All 3 of those classes are really hard. So what we're trying to do is change your opportunity from 1/3 of you passing to just over half of you passing, right? We're trying to give you that skill, and we're trying to go slow enough that you can absorb it. Because when you get to 238 and 259, trig and calculus, we're covering so much material, there's very limited review. Okay, now, let's say you cheat. You pass the class, and then you take that next class, okay? Business calculus. Financial aid will never pay for you to take this class again. So what happens every semester is I teach 238, and then I'll have students who had no chance of passing. They tried, they worked really hard, they had no chance of passing. And then I'll have a conversation with them, and I'll go like, what happened in Math 125? And they go, I was a marginal C student. I barely made it. A lot of it was teacher thought I was a nice person, felt bad for me, helped me out. And then they get in this class, and I absolutely slam dunk them. Okay. Now, what I usually do with those students is I say, hey, in the summer and winter, take 238. Don't take it for a grade. Just sit in the class, and every time we cover something that you don't need, I'll tell you to ignore that section. So I have students doing that now who are in my old 238 class. I have students that did that last semester. He got an A in 125. He had flunked 238 3 times. He had no chance every time. When I finally had a conversation with him, like, look, you got no chance. Came back, was serious about this class, and then he just finished with an A. And it wasn't even a low A, it was a high A. Okay. So the reason why we're doing this is so that you have the skill to survive in your next class. Because this class is optional, completely optional. Don't cheat because you want to know if you're ready. Let's say you flunked this class. Doesn't harm you at all. It only harms you in terms of whether you're on probation or not. Okay? But you can take 134, take this class, it starts at an easier level, finishes at the same level, and we have 15 weeks instead of 5 weeks to cover all the material. Okay? So financial aid will pay for that because you didn't pass this. So please don't cheat. When we talk to the other professors where we go like, what do you do to prevent someone from cheating on XYZ? Just having their friend do it. Like, nothing. Like, there's nothing we can do. There's no way of monitoring you. They have monitoring systems, and we tried it. We've tried the Proctorio, and so different teachers tried cheating different ways on it, and every one of them was successfully able to cheat. So we just decided, look, if you cheat, we're just going to like flunk you in the next class. Because the people who cheat in this class, only 1/3 of them pass the next one. So we're going to just flunk you. It's not a problem, right?
Professor?
Yep.
What class is 238?
238 is business calc.
Okay, and then what's 259? Is that trig with pre-cal?
Trig with pre-cal, yeah.
Okay, do you teach 259?
I try to, but they never give it to me.
Oh, okay. So is there a chance of you teaching it in the fall?
No chance.
Okay,
I think for a while, so part of the problem is this. This is an optional class, right? So if you give a teacher who has a bad rate my professor rating on 134, since it's a completely optional class, no one will take that class. Right? Why take an optional class from a guy who's a jerk? So they keep me in here because my rate my professor, I think I have the best ratings from all the other professors, full-time professors. I think my rating is high, so my class always fills first. And then, yeah, and then a lot of you have been like told like take Kauai. Like a lot of counselors will recommend me. A lot of disability counselors will recommend me, and I think the Black Student Alliance, I think the African American counselor, I think he recommends me also. So because I can fill this is all about money at the end of the day. More classes we have, the more money our department has. Every time we cancel a class, we have to fire someone. I mean, that's just what it is. So they put me in this class because I have the kind of reputation that can fill it. And when they've put other people in this class, they just can't fill it. So they're probably going to keep me in here tactically to make sure this class doesn't die. And then they've been giving me 238 because then the number of units for both matches the 15 units they have to give me because I'm a full-timer. So I'm probably going to stay like that for a while unless regulations change.
Okay.
Are you going to teach this class in the fall?
So in the fall, I teach 134, which is a same class, but we start at an easier level.
Oh, okay.
Okay.
Professor?
Uh-huh.
How many classes do you teach a semester?
I teach, basically I teach 2 a semester.
Oh, all right.
And I'd like to teach more. See, there used to be a time where if you were a math teacher, you could get as many math classes as you wanted. But now that we stopped teaching algebra because the state said you're not allowed to teach algebra and pre-algebra, 85% of the students who came into this college needed Algebra 1 or Algebra 2. And 50% of them start from arithmetic, meaning they take Math 110, Math 115, Math 125. And so they've cut those bottom two classes. And it used to be everyone, almost everyone who came in here took those first two classes. So we literally went and fired half the teachers. And the entire state of California, if you want to be a math teacher, we went and just fired half the teachers. Now I knew this was going to happen, so I actually went to Cal State LA, and usually I go there. I run a workshop on how to write resumes, how to do interviews, because just because you got a degree doesn't mean anyone hires you. So I'm pretty good at helping students make that transition from student to professor. And then they asked me 3 years ago to come up there and give my same workshops, and I went up there and I said, there will be no jobs for you. You are studying for a job that will not exist. We will fire half the teachers, all who have experience, and they will be milling around California. And until they go away to other states, there will not be a job for you in California. And they're like, well, this is a sucky seminar. But I told them, like, you need to have options because there will not be a job for you here in 2 years. The world is changing. So I went there, and then in the last 2 years, I don't think any of them have gotten jobs. So I teach some version of this class in the summer and winter. And then I usually teach, they've been giving me business calculus a lot. But, I like this class. I mean, if you see me here, I don't look unhappy, right? Okay. So let's keep going. So find slope and Y-intercept. Okay, go ahead and try doing that problem. So you'll get minus 5x and you'll get 2y and then you'll divide everything by 2. No, write down the slope and write down the y-intercept. Okay, so this right here, that right there. Okay, don't forget the sign and make sure that you don't include the x in your answer. Okay. Now let's do the same for this. Okay, so it's already in slope-intercept form. Okay, now the way you want to think about this is that this is y is equal to 3x plus 0. Okay, so this right here is your slope. And then your y-intercept is equal to 0. Now, we're going to do the same thing, find the slope and y-intercept for y is equal to 5. Okay, now, we're going to use the same trick that we did here. What's missing is the x. Okay, so go ahead and write down the slope and the y-intercept. Okay, so these directions are for this, and these directions are also for that. Okay. So my slope is equal to 0, and my y-intercept is equal to 5. Now we're gonna do the same thing here. We're gonna go up there, right? That instruction is for that and for this, and then we're gonna do something different. We're gonna do x is equal to 3. Okay, so go ahead, copy. I want to give everyone a sort of the chance to sort of look at that and digest. So let's look at this. Okay. Now, all of these have a y in it. So if it's possible to isolate the y, you just isolate the y. And anything that's missing, you just make it equal to 0. Okay. Now over here, this one has no y. Okay. So the easiest way to do it is to graph this and then to look at it. Okay. So we are going through the x-axis at 3. Okay. We're going through the x-axis at 3. And then we're saying, what's my slope? Well, the slope of something horizontal is undefined. And then in terms of the y-intercept, so where does this line hit the y-axis? It never does. They're parallel to each other. They never touch each other. So these two never touch each other. So then it's undefined. Now, I definitely know this is on your homework. This is on your homework also. I'm not sure if these two are, but definitely this one is on your homework. So this one's definitely eligible for your exam. Okay? It's a little trick one. Okay, now that we've gotten to know each other, right? So let's strategize it, okay? The only questions I can give you are the questions that are on the XYZ homework. So on Friday, what I'm going to do is on my old exams and on my old worksheets, I'll tell you what problems I would have given you if I had given you a written exam. Okay. Now, what I would do if I were you is I would go through the XYZ homework and make sure I know how to do it, and I make sure I know how to input my answer incorrectly. Okay. I would make sure I'm really good at the XYZ homework. Now, for some of you where you go, I'm going to go to trig, and I just want to make sure that I have a good sense of how to do this stuff, then go through some of my old questions, because I can only ask what's on XYZ. I can't ask as rich of a palette of questions that I want to ask. So for those of you who are trying to get to calculus, go ahead and go look at some of my old exams. It's not going to hurt you, and it might give you a little more richness in what I normally would give if we weren't in a Corona situation. Okay. And for those of you who are in survival mode, where I've just never ever conquered this, I would do the worksheets, because they're going to go over the specific stuff that I always put on my test. And then I would go over the XYZ and repeat the questions that you screw up. Now, what I normally do when I study is that when I do homework, for each section, I write down what problem I think is going to be on the test. Because you see the lecture and then you do the problem and you know the ones you have trouble on, and you know the ones that look like, that looks exactly like what he did in class. I write it down. So for 3.1, 3.2, 3.3, as I go through the section, I do those problems first. So if I run out of time, the problems I do first are the ones that I make note during my homework that these are most important. Okay. Now the same thing's going to happen when you go to 259. I think all the 259 teachers, what they're doing is having you, they're giving the test on Canvas, and then you write everything down, and then they scan it. So it's like a race. You're going to do your test during the class time that they normally would do it. So you're having to do it with everyone else, just like this was a regular class. And then they're giving you extra 15 minutes to cut and paste that into a Word file and then email it back to them. So you take pictures of it, you put it in a Word file, and you email it back to them. So they're going to give you a richer set of questions from when I've been talking to them. That's how they're attacking this.
What class is that for?
259.
Oh, okay.
Yeah. And what they have told me that roughly the same people who were passing before are passing now. Okay. I know the calculus teachers are doing that also.
Professor. About the practice quiz, is it going to be like during class on Friday, or are you going to post it on XYZ as homework after the lecture?
I'm going to post it. Well, I'm going to post it on XYZ as homework, so you could do it whenever you think you're ready.
Okay.
Just take the test and see if you're ready. That's all.
And do we have the 48 hours just like the homework, or
48 hours, just like, yeah. So I'm not even going to give you a grade for it. It's just going to be there.
Yeah,
you
it's
can
just
do it anytime
practice.
you want. Yeah.
Okay.
And you just have a sense of like, okay, he's going to ask me this many questions around this difficulty, and he's expecting me to do it in this much time. So at least when you're taking the test, you know what pace you're supposed to have.
Right.
Right.
You know what to look out for.
Yeah.
And the quiz will also be on the XYZ?
The quiz will be on XYZ, yeah. So you'll see a little thing that says quiz, and then it'll turn on. It'll turn on at 5 o'clock on Sunday.
Thank you.
Professor, I have another question.
Sure.
Can we take the practice quiz more than once?
Yeah, I'll leave it there for you to take it over and over and over again. And then every time you take it, they should flip the numbers.
All right. Thank you.
Okay. Yeah.
Professor? So when are you going to post the practice quiz? On
probably sometime on Friday. So I don't know what I'm going to cover tomorrow, just because whenever I get questions, I just stop. And if I don't get questions, I go faster. So usually what happens is right after Friday, I sit down and tell you I write down what to study. And then I write down, then I'll write your quiz. And then after I write your quiz, I'll go through it and give similar types of questions on your practice quiz. So you're probably looking early Saturday morning, late Friday night.
Okay. And the actual quiz is going to be on Sunday, right?
Start on Sunday. So anywhere from Sunday, 5 o'clock to class on Tuesday. I'll make it 8 a.m. Tuesday morning. So you have like a big window.
Okay. Thank you so much.
Yeah. I know some of you need to put your kids to sleep before you take it. I know some of you need to take a nap after work when you take it. Like, I was a parent going back to school at 40 with a job. So I get all of those constraints, which is why I'm going to have the open window. So I want you to sleep and then take it.
Okay, thank you.
Okay.
Okay.
All right. Now,
Professor?
yep. Someone had a question?
Yeah. So is the quiz that you're gonna put on Friday or Saturday, is that similar to the homework? Like if we like for example, me on like some questions or homeworks, I was getting half of the answer correct, and then it would break down the other half that I didn't get correct, and then I would go back and I forgot stuff. Is that something similar that's gonna happen on the quiz?
Yeah. So what's going to happen? It's going to be even worse, right? So I'm going to literally go through your homework. I'm going to pick question 4 from section 3.1. It'll be exactly the same setup, just that these questions, they randomly generate new numbers.
And they're timed, right?
And they're timed. Okay. So if you're going like, I'm not getting them 100% get correct, I'm getting, I make a mistake on a step, then you're going to get the question at 100% wrong, right? Because there's no partial credit on these.
Yeah. Okay.
Okay. Okay. Now, the XYZ limits me in that I can't ask a lot of questions on vertical and horizontal lines, only because they don't have a lot. So just know that I know that this is one that most likely will be on your test, just because I don't have a lot of options with horizontal and vertical lines. So I would put a little star on that one, that you're going to want to care about this one. Okay, so let's go to the last part of 3.1. I didn't finish it, but I'll finish it tomorrow morning. Okay, but let's go to the last part of it. You can start it. I haven't done the middle questions, the graphing questions, but I will have finished the first questions and the last questions. So if you want to start it, you can. Okay.
And 3.2 homework will be available on XYZ?
Yeah.
Okay.
So you can go, even though it's not in the calendar, you can go down to 3.2 and click it. So let me show you.
Professor, so
Uh-huh.
the 3.2 slope is also part of 3.1, or is it different?
It's different, yeah. So right
Okay.
now, I'll only make 3.1 and 3.1 do. Okay, and then usually I take 2 lectures, 2 hours to finish the section. So we're actually in a good place. Let me sort of show you. Okay, let's go to here, and let's go to okay. Now, when we go down to here, so even though I don't put 3.2 up here, like let's say you don't see it, even though you don't see it, it'll be down. You can always access it by just going down to 3.2 and clicking on there. Okay.
Professor?
Clicking right there. Yep.
The problem is that I try to click on it and it says that the assignment's past the due date and I'm unable to do it.
Oh, really? Okay.
Yeah.
I will fix that for all of them. So in the future, you should be able to do all of them. Okay.
Professor?
I'll fix. Yep.
If I try to go look at like yesterday's homework assignment,
Yep.
it tells me something about a late pass, but I don't know what that is.
Oh, okay. So let's say you don't turn it in within 48 hours. Then
So I did turn it in, but like if I wanted to look over it, I can't look over it.
Oh, just click late pass and you should be okay.
Okay. Thank you.
Yep. Okay, now. Yeah, so if you can't see it, let me know, but you should be able to hit late pass and it should work. Okay, so let's get going. Let's finish this up. We're almost there. Okay, so let's work on parallel and perpendicular lines. So let's say I have 2 lines that are parallel. Parallel lines never intersect.
You're still sharing the screen.
Oh, am I still sharing the screen? Thanks for letting me know. Okay, thank you. All right, so parallel lines never intersect. Now, they're going the same direction. Okay, so since they're going the same direction, they should have the same slope. So the way you can tell that 2 lines have the same are parallel by just looking at the equations is that they should have the same slope. Okay. So what's going on here is that I have 2 lines. Their y-intercepts are different, but they're going in the same direction. Perpendicular lines, they form a perfect cross. They form a right angle. So I have y is equal to 2/3 x, and then y is equal to -3/2x. Okay. Now these are called negative reciprocals. Okay, now let me break that down. Reciprocal means that 2/3 and 3/2, they're flipped. Negative means that they have opposite signs. So this part right here means you have opposite signs. And then this one right here means that they're flipped. So both things need to be true. They have to have different signs, and the numerator and the denominator have to be flipped. Okay. So then the question will look like this. Are the lines parallel, perpendicular, or neither? Okay, so I'm going to run out of time, so I'm just going to put the 3 questions up. I'll leave it there for you guys to copy it, but I just want to make sure I finish talking by the time this is over. Okay? So this one is perpendicular because the slopes are the same, right? So go ahead, don't copy. I just look up because I'm going to go a little fast, and I'll leave it for you guys to copy. Now, if we have something like this, that is neither, because even though these are reciprocal, they're not opposite sign. Neither means that they're just 2 lines that cross each other. There's nothing special about them. They're not parallel, they're not perpendicular, they just cross, and that's it. Now this last one will be perpendicular, so I'm going to make it almost exactly the same. So this will be perpendicular. And the reason why is that these 2 are opposite sides. So the way you can tell whether something is parallel, perpendicular, or neither is that you have to convert it into slope-intercept, and then you're just looking at the slope. You're not looking at anything else and making a comparison. Okay, so I made it at exactly 11:30, but I will hang out and leave this on. And if people have questions, go ahead and ask me questions, but I'll leave this open for people to copy.
Professor?
Mm-hmm.
So to completely understand you, the parallel one that you just made, because the slope, they have the sign, and then the neither is because there's no different, like there's not a negative or anything.
Exactly. These are the same sign. In order for it to match this one, they have to be opposite sign.
Okay. Okay, thank you.
Yeah, okay. So let me kind of make that. These are same sign. And these are opposite sign. Did anyone else have questions? Okay, so I'm going to leave. Go ahead.
I have a question way back to the find the slope from 2 points.
Yeah.
And so when you give us 2 points, for some reason when I tried to do it, I got the answer wrong. So the first point, I would put the first number as x1, a second number as y1.
Oh, okay. So let's try it together. Let's do one together. Okay.
Okay.
We'll walk through the steps together. So I'm gonna erase only this part and leave that part out there.
Somehow I think the number is like the opposite from what I picked. That's why I'm confused.
So let's look at this one. So let's say we pick 2 points. 2 comma negative 3 and 5 comma, let's say negative 7, like that. Okay. Now, there's a couple ways of attacking this problem. One way is to make this one x1, y1, and to make this one x2, y2. The other way of attacking this problem is to make this one x2, y2, and this one x1, y1. Now, for me, I get confused with all the little subscripts. An easier way of attacking this problem is that if you look at it this way, you're going to subtract these 2 numbers. And these numbers are going to be on the top. So you'll go -3 minus -7. It might be easier to just stack them and just say subtract the y's and then subtract the x's.
So why isn't it oh sorry, I got it now.
You got it now?
Yes. So you go from the first one to okay.
Okay. Now it doesn't matter whether, so the key is this. Okay, so this turns into 4 over -3. Now, if you instead put these first, -7 minus 3, 5 minus 2, you'll still get the same answer. The only difference is the negative will be in the opposite location. Okay, Now, this number and this number are the same thing. Even though this negative's on the bottom, it really goes in the middle. Really, though, even though this negative's on the top, it really goes in the middle. Because a positive divided by negative is a negative, and a negative divided by a positive is a negative. So they'll be the same. The only difference is the signs will be opposite what they were before. But when you write it, you'll put the negative in the middle.
I see. Thank you very much.
Okay, no problem.
Excuse me, Professor?
Yeah, what's up, Simon?
How do you recommend we study for the SAT?
What year are you right now?
I'm going to 11th grade.
Okay. It sucks that you're not in 12th grade right now. Do you know if they're requiring the SAT for you?
It's required for all other schools except for UCs, I think.
Is it? Okay. Because I know a lot of schools have gotten rid of it. What I would do, okay, so the first thing you want to do is this. Always study off of the study guide from the people who author the test. So make sure you have the right study guide first. So let's take a look at that, okay?
Okay.
So in terms of Amazon, and this is true of any test, whether it is, what's your major?
I'm going into medicine, but I don't exactly know my major yet.
Okay, so like when you're studying the MCAT, you always, so there's all these different companies, Princeton Review and stuff like that. They're guessing what's on the SAT. You always want the official study guides. So I think it's, and a lot of them will say official, but let's see. I'm trying to remember who does the SAT. That's by, not ATI, that's ETS. Not Barron's. Let's look it up. Who writes the College Board? That's it. Okay. So the first thing you want to do is get the College Board. There you go. All right. So get the one that says from College Guide. College Board, here we go. So this is the one that you want to study first. So the first thing you want to do before you pay anyone a penny is you want to do all of these tests. Okay, now the SAT has not admitted this, but people have done studies on the SAT. Now, normally when you tell a student, when you guess a question, always guess C. Because if you have a teacher writing their own exam, C is usually the answer that they pick the most. Okay. Now, knowing that this is a thing that students do, what the SAT does is that for every section, they have the same number of A's, B's, C's, and D's. Okay, so when you're guessing, so there's it's called the Mighty Mouse guessing strategy. So as you're going through your test, for each section, the number of A's, B's, C's, and D's are roughly the same. So people have gone through the old exam. There's a professor from Israel. She went through like every SAT. She asked the SAT, and they go, "We absolutely don't do that." And then she went and looked at all the SATs, and absolutely they do this, where the number of A's, B's, and C's are exactly the same. So as you do your questions, tick mark them. And when you're not sure, what you do is first cross out the questions that you know 100% are not true. And of the letters that are left, the one that has the fewest tick marks, that's the one that you click, because that's the one that has the most open answers that are still out there on your test. So the main thing I would do is, one, I would do the official study guide before I pay anyone a penny. and then know what you don't know, right? And then you go and maybe you take a study guide, and since you've seen it, every question you don't know how to do, you circle it. So when you finally do pay a person to work with strategy with you, you know exactly what you want and go, this question right here, how do I attack that? So what you want to do is be smart about your money. But in terms of guessing strategy, that's the best one that I know of.
Professor.
Uh-huh.
Would you recommend a tutor? Like if there is something you are struggling with and you know that you might need help, would you recommend buying a tutor? Like, do you know if it works? Like, do you know people who have told you this works or it doesn't?
It's all about time. So are you a Valley College student right now? Like you have a valid ID?
I mean, I'm still in high school, but I have a student ID number.
Okay. So one way to what I'm always trying to do is do it the cheapest way possible.
Of course.
So one way to attack it is you can use which topic are you most concerned about? Is it the reading or is it the math?
I mean, I'm stronger in math. I think math is my best subject, but I'm just saying if I do encounter something like English wise or math wise, either way that I need help with, do you recommend a tutor?
You know, it's really hit or miss.
Because I know I could just go look it up, but I don't know if that is effective, as effective.
You know, I usually find just doing a lot more tests the most effective thing, and then asking. You might pay someone to break it down, but look, if you go on Craigslist and just say SAT tutor, you'll see a whole bunch of things that pop up for like $20 an hour in terms of places that are hiring. So the people who hire the SAT tutors, these sort of like, will teach you how to do it. All they do is hire someone like me, and the person might be good and the person might, it's really random. I mean, they're literally taking people off the street and say, let me see your SAT. Oh, you seem like you did a good job. Teach these people because we're going to charge them $70 an hour. We're going to charge you $20 an hour, and we're going to make $50 an hour on them. So like when you go like, how confident am I in terms of these SAT programs? I'm not very confident because I'm the kind of person that they try and hire. My friends are the kind of people who actually do it, like other people that I work with. And, you know, they're really hit and miss on whether they're helpful or not.
Okay. Thanks.
So what I would do is I would know the questions you're not sure about, and then hire someone to say, explain these to me. And if they're no good, dump them, and then hire the next person on the Craigslist.
Right.
Right. So there probably are people that are more talented than others, but don't trust like Princeton Review or any of those places because who they hire is random.
Okay.
Okay. Yeah.
Thank you.
Professor?
Uh-huh.
Would you be able to show me one more time how the tutoring online works for the 24/7 one?
We could try it. I'm not sure. I've never done it, but let's try it together. Okay. So what we're supposed to be able to do is we're supposed to be able to go to Canvas. Sorry, so let me log in. Let me try share screening with you, so we'll discover this together.
Okay.
So we go to Canvas. And the 24/7 one is, I think, NetTutor, right?
Yeah.
Okay, so we go into 125. And last time I saw them, it was on the side over here. Let's see if here we go. This NetTutor right here. Do you see that on the side?
Yeah.
So let's click on that. And then we agree not to sue them. And then we need help in math through pre-calculus. Okay.
So it would be math pre-calculus.
Yeah, yeah.
Okay.
We're below pre-calculus, yeah. And then I guess it'll just come up then.
Okay, perfect. Thank you.
Okay, thank you.
Have a great day.
You too. Anyone else have questions?
Professor,
Uh-huh.
you told us that you're gonna start dropping off people from Wednesday, starting Wednesday, people who are not registered in XYZ homework, right?
Yes.
So if you accidentally drop me, for